Hey there, Kipsters. We're looking at our 7th grade practice CST, and we're looking at questions 36 through 40. Mr. Craig made a scale drawing of his office. It's 2 inches tall. You can see the scale is right here, that 1/2 inch equals 3 feet. So the width of the scale drawing of the office is 2 inches. That's what's labeled in the picture. What is the actual width in feet of Mr. Craig's office? I'm going to show the answer in 2 different ways. The first is if I have 2 inches on the drawing, I know that that's really 1/2 an inch, 1/2 an inch, 1/2 an inch, 1/2 an inch. This would be 1/2, this would be 1 inch, this would be 1 1/2, this would be 2 inches. And the reason I'm breaking into 1/2 inches is because I know that 1/2 inch equals 3 feet. So if a 1/2 inch equals 3 feet, that must mean that 1 inch equals 6 feet, that 1 1/2 inches equals 9 feet, and that 2 inches equals 12 feet. Already I know, just using the picture, that in the real world this is going to be 12 feet. To be absolutely certain though, I can also do this with the proportion, and I know that 1/2 of an inch is the same thing as 3 feet, and so I can write a proportion to say that that would be equal to 2 inches, and I want to figure out how many feet that would be. So I can rewrite this as 1/2 is really 0.5 inches over 3 is equal to 2 inches over x. So to solve this I can cross multiply and divide. 3 times 2 is 6, and 0.5 x is there. I need to then divide by 0.5, divide by 0.5, divide by 0.5. My 0.5's cancel out, and x is equal to 6 divided by 0.5. So if I divide 6 divided by 2, it would equal 3. It would get smaller. If I divide 6 by 0.5 or divide 6 by half, it's actually going to get bigger. And 6 divided by 0.5 is 12. And so either way I do it, I can see that in the real world it's going to be 12 feet. Moving on, question 37. What is the length of the missing side of the triangle? I can see a right triangle, so immediately I think I'm using the Pythagorean theorem, which states that the sum of the squares of the sides of a right triangle are equal to the square of the hypotenuse. So if I can label the sides, I should be able to plug this information in. I can see that I have one leg, A, is 15. Another leg I'm looking for, question mark, but the hypotenuse, the side that's longest and across from the right angle, is 17. So I'll plug those things in. A squared is 15 squared plus B squared I'm looking for equals C squared, which is 17 squared. 15 squared is 15 times 15, that's 225, plus B squared equals 17 squared, which is 17 times 17, or 289. I cancel the constant by subtracting 225 from both sides. And I have these cancel out. B squared is equal to 64. To solve it, I find the square root of both sides. And square root of B squared is B. Square root of 64 is 8. And so if A is 15 and the hypotenuse is 17, I can see that missing side is a length of 8, which is answer choice B. Moving on, 38. In the figure below, AB and CD are perpendicular, so that means AB and CD form a right angle when they hit. You can see there's information labeled. It's asking for the perimeter of ABC. So ABC is this big triangle, and when it's asking for a perimeter, that means whatever the length of the 3 sides are, I need to add them up. So I have A, B, C. I just need to add up the sides. I can see that side BC is 15 long. I can see that side AB is 14 long. My question is, how long is AC? How long is AC? So to figure that out, I can use the Pythagorean theorem to figure out how long AC is. In order to do that, I'm going to need to use the Pythagorean theorem. I will need to know how long is this leg, which is 12, and I need to know how long this leg is. I don't know how long this leg is yet. So first, I need to figure out how long is this leg. So if I figure out how long this leg is, then I can figure out how long this piece of the leg is. This is kind of a tough question. So first, do I have a different color? I do. My first job is to figure out this blue side of DB. And so to do that, I'll call this leg 12 as A. I don't know how long B is, and I'll call C 15. Because in this right triangle, 15 is the right angle. And so what that means is 12 squared plus B squared equals 15 squared. And I'm going to solve for B. 12 squared equals 144 plus B squared equals 15 squared, which is 225. I subtract my constant. And B squared equals 225 minus 144, which is 81. Find the square root, and B is equal to 9. So what I've just figured out is that this blue side here is 9 units long. And so the reason that's helpful for me is if I know that this side is 9, and I know that all of AB is 14, I can now figure out how long this leg is. And this leg plus this leg should equal 14. And 9 plus 5 equal 14. And so the reason that's valuable is now I have the two legs for this triangle here. I know this leg, I'll call this 5 my A for this right triangle, because really the right angle is right there. I'll call the 12 B, and I'm looking for this side C. And so I'm going to use the Pythagorean theorem again, twice in the same problem. I know that A squared plus B squared equals C squared. A squared is 5 squared, plus B squared is 12 squared. And I want to figure out how long this side is, which is C squared. 5 squared is 25, 12 squared is 144, equals C squared. 25 plus 144 is 169. So to solve it, I need to find the square root. The square root of 69 is 13. So that was a lot of work to figure out that this side here is 13. And so to connect that to what I was looking for, I wanted to figure out how long AC was. I now know that AC is 13. And so if it's asking for the perimeter of A, B, C, I just need to add 13 plus 14 plus 15. If I do that, 13 plus 14 plus 15 equals 42, and that's the total perimeter. Moving on. Jared scored the following number of points in his last 7 basketball games: 8, 21, 7, 15, 9, 15, and 2. What is the median number of points scored by Jared in these 7 games? So I know when I think median, I think middle. But the very first thing I need to do is write these numbers in order. So I'll write these in order, starting with 2. I have 2. Cross it out so I don't repeat it. 7, 8, 9, 15, and 20. Oops. There's a second 15. And then 21. So if I want to find the median, I just need to find the middle value, which I can see is 9. So the median is 9. And that's the correct answer. Last question for this video. The box and whisker plot below represents the daily high temperatures at a beach in April. So these are the high temperatures at this beach all month. What was the median daily high temperature? I remember when we created box and whisker plots that in the middle of the box is the median. So that value, it's not exactly in the middle of the box because the temperatures aren't evenly distributed, but that line is where the median is. If here's 70, here's 80, I can see that looks like since there's 5 lines, this is going by twos. 70, 72, 74, 76, 78, 80. And so this, where the median is, should be at 72. So the correct answer is that the median temperature is 72 degrees.